I welcome you all in this video. In this video, I'm going to talk about the very important concept from the machine design, that is factor of safety. So just let us start this concept. Now, while designing a component, it is necessary to provide sufficient reserve strength in case of accident. So every design engineer has to provide sufficient reserve strength for the component that he is designing. Here, the case of accident means the situation where the magnitude of force increases beyond the expected load or force, which may result into a failure. Many times it happens that whatever the load for which the component is designed, that load may get increased because of uncertain situation, because of unknown situation, and that increased the load beyond the expected load may cause the failure of component. The failure of component may be either permanent deformation or permanent breakage. So in such situation, we must use factor of safety in order to provide sufficient reserve strength to component. Now this reserve strength to component reserve strength to the component is provided by using factor of safety, which is denoted by F suffix S. So the reserve strength that needs to be provided to the component, it is provided by factor of safety, which is denoted by small f suffix S. Sometimes this factor of safety is written as F dot O dot S. Okay, so you just remember this, it is denoted by F dot O dot S, factor of safety. Now the factor of safety is defined as it is the ratio of failure stress or maximum stress to the permissible stress, permissible or allowable stress. So this factor of safety is defined as, it is the ratio of failure stress, or it is also called as maximum stress, upon permissible stress, which is also called as allowable stress. So this is the definition of factor of safety. It is the ratio of failure stress to the permissible stress. Now we'll discuss what is meant by this failure stress, what is its value for ductile material, and what it is value for brittle material. Similarly, we will discuss about what is meant by permissible stress and what is the value of Fs for ductile and brittle material. So first of all, you should know that what is meant by permissible stress. Which we also called as allowable stress. So remember that this permissible stress or allowable stress is the stress which is used to determine the dimensions of component. It is the stress which is used to calculate or find the dimensions of components, and every design engineer wants to keep the induced stress in the component lower than this permissible stress. Okay, so this is very important point. So for a design engineer, the permissible stress is the stress below which the induced stress must be there. So now the next point is, every design engineer designs the component in such a way that to keep the induced stress well below the permissible stress. So this is the aim of every design engineer, that they design the component in such a way that to keep the induced stress in the component well below the permissible stress. Okay, if such thing occurs, that means if the induced stress is less than permissible stress, then designer calls such a design as a safe design. Okay, so you remember that when the induced stress is less than permissible stress, then and then only designer say that that design is safe. Otherwise that design is not safe. That is stated by a design engineer, or design engineer can say that if the induced stress is not less than permissible stress, that design is not safe. Okay, so this is about the permissible stress. Then from this ratio we can find out the permissible stress in this way. So permissible stress, which is already in the denominator in this ratio, in this definition of factor of safety, we have to take on the LHS. So if you take this permissible stress on the LHS, this Fs will come into the denominator. So we can write permissible stress is equal to failure stress upon factor of safety Fs. So by using this equation, from this we can find out the permissible stresses for different types of loading conditions. Now next is, we have seen that what is meant by permissible stress. So permissible stress is used to calculate the dimensions of component, and every design engineer wants to keep the induced stress in the component well below the permissible stress. Then and then only that design of component is safe. Okay, so next is failure stress. So next is failure stress. So this failure stress is nothing but, it is the stress at which actual failure of component takes place. It is the stress at which actual failure of component takes place. For example, failure stress for ductile material, failure stress for ductile material is SYT, that is yield strength in tension. Similarly, failure stress for a brittle material is SUT, that is ultimate strength in tension. So that we have discussed in stress strain curve, that failure stress for ductile material is SYT, not SUT, because for ductile material the first failure occurs as permanent deformation. Okay, and later on, if the stress increases, the next type of failure in ductile material is permanent breakage. Okay, so as the first failure in ductile material is SYT, so we have to take failure stress for ductile material as SYT, because first failure is permanent deformation. And for brittle material there is no elongation, there is no yielding, so the only one type of failure that occurs in the brittle material is the permanent breakage, that means which occurs at SUT. Okay, so when the induced stress in the brittle material reaches or exceeds SUT value, brittle material fails. Similarly, in case of ductile material, if the induced stress reaches SYT or exceeds the value of SYT, then the permanent deformation of ductile material occurs. So that's why we call this SYT as a failure stress for ductile material and SUT for a brittle material. Okay, so just for your understanding, I will write for this ductile material, for ductile material, when the induced stress exceeds the value of SYT, then permanent deformation occurs. That is, we called it as a yielding takes place. And for brittle material, the failure occurs when the induced stress in the component exceeds the value of ultimate tensile strain, that is SUT. And when this occurs, when the induced stress becomes greater than SUT, component get breaking occurs. Okay, so induced stress, when it becomes greater than SYT, permanent deformation occurs, and when the induced stress becomes greater than SUT, breaking occurs. This is for ductile material failure, and this for brittle material, this type of failure occurs when such conditions occurs. Okay, now the last point is factor of safety. Magnitude of factor of safety. Magnitude of this factor of safety, Fs. So the general guidelines are already there, that for ductile material, the value of Fs can be taken as from 1.5 to 2, and for brittle material, the value of Fs can be taken as 3 to 5. Okay, and many times student come across one question, that what is the minimum value of factor of safety. Okay, so just remember that the minimum value of Fs is not 0. Remember that the minimum value of Fs is not 0. The minimum value of Fs is 1. We cannot decrease the value of Fs less than 1. So minimum value of Fs is 1. So you should remember this. Okay, and you can imagine that you can easily find that if the minimum value of Fs is 1, that is when you put here Fs is equal to 1, you can get permissible stress is equal to failure stress. Okay, and that means when you are using Fs is equal to 1, that means you are not providing any safety to the component, because if Fs is equal to 1, directly permissible stress becomes equal to failure stress. That means in such situation, indirectly you are not providing any safety to the component. So this is about the concept factor of safety. If you have any question related to this concept, you can mention in the comment section.